Okay folks, so now we're up on the top and in the courtyard. So Jake is actually looking at just one of the wings of this thing. We've got another entire wing here behind us that hasn't even been started yet. So that's going to be an interesting one to see what happens in there. And then of course the huge chimney that Chris has already rebuilt. And then this is the central portion, the medieval hall structure that's buried underneath all sorts of funny things at the moment. So let's pass on to Jake and he's going to take us through what's happening from this side. You'll get a close-up of some of the repairs.
Okay, yeah, so we're sort of in the valley area here. We might as well start with the walls that we've been working on for the last very long time, so the last year. So yeah, I get loads of repairs along here, a new post, sole plate down on the bottom that you can't probably see, but yeah, that was a huge operation. You can see there's lots of repairs in this corner here, and we've got this big repair up here, which when we chatted with the structural engineer, this was just such a mess around here. We had a failed tie beam, we had a snapped wall plate. The conclusion we came to is we put a solid timber that would serve to become a wall plate as well as an extension of the tie beam over there. That was quite an interesting repair to do. As I say, I've never done one before, but it's worked. As you can see, we've got a nice solid wall plate. We've left it overhanging for a scarf joint so we can tie it into the next wall plate. Tie beam is sat nicely.
Just take us through what you did with that, because that is one incredible piece of timber work in there, Jake. I don't know whether people can see with the camera, if you can maybe just pick out the points of it.
Well, it all started with a level line, basically. A level line that went from the truss across the old wall plate and to the new tie beam. And basically everything, all of my measurements just came up or down or left or right off of vertical, perfectly vertical or level lines, basically. And yeah, it's a lot of measuring, a lot of double checking. It was complicated because we've got one angle here where the tie beam is, and then it has to change direction. This timber isn't straight. It comes in at an angle here, it changes direction for this plate, and then it actually changes direction again. So it's almost in a zigzag sort of shape, so that everything lines through nicely. So yeah, it was an interesting thing.
So just to point out to folk, the whole thing starts with this huge great joint, which is scarfed onto the end of the tie beam, which takes a huge truss here, this big triangle of timber. So he started with that tie beam and then connected onto the blade of the truss there, and then that had to connect to a completely different part of the building. This is the huge corner post on a new section of the building, and he's managed to actually joint that tie beam and the base of the truss onto the wall plate. And as he says, it needed an angle, and then this is the timber going out and starting to tie together the wall plate for the whole of the rest of the building. It's quite an extraordinary piece of work.
I'm not really sure how I managed to do it myself when I look back at it now. But we got there.
You did indeed, Squire. And now you've got to attach the so that wall plate.
That will have another scarf joint sort of cut on that angle there roughly, and then jointed on in a similar fashion going that way.
Right.
And then running out to the end of the building there.
So some of this wall plate is coming out.
Yeah, we are going to try and keep a section. We've got a pretty good section in this bay here. We're going to try and keep, try and maintain as much of that historical fabric as possible. once these plates are all in, we'll be ready to put the trusses back on. We'll have a nice solid structure again for the first time in a long time. Yeah.
Right. Okay, so take us through.
Moving up from the wall plate then, so going up the roof here. These are the huge purlins I discussed earlier. You say they literally go from the end of the building, one solid piece of timber, right the way through to that truss at the end there.
I'm just going to show folk, here we go, we're zooming in on that, the end of that purlin.
Normally, standard practice would be to joint your purlins over the truss there, but these guys just found the biggest tree they could find, split it in two, and got it in there.
So that is one huge piece of timber coming right the way along, all one single piece of timber all the way across to that big truss that you can see at the end there, that far truss. So that's a distance of what, about 12 meters, is it? 12?
About that, yeah, with the
12
overhang
meters
on the end. Yeah.
Wow. So we have two of those coming off. You can see there's the lower one, and then there's one across the top here in the middle of the picture. You can see both of those are going to come off tomorrow, and the corresponding ones on the other side of the frame. So,
yeah.
What else?
You may have noticed we've got a diagonal windbrace up here, but then we're missing one on this end. Folks, please don't cut your braces out of your house. They are doing something. So at some point someone's cut this windbrace out here, so we'll need to reinstate that to again add more,
see
racking strength.
that it's been chopped out, and then up in the top in the purlin there you can see the
mortise up there for it.
To zoom in on it, that mortise. I think you can see very clearly there now. There you go. That's where that brace would have fitted. As Jake said, it stops the whole thing from racking over. You've got a structure like this that can move that way or the other way. It wobbles around all over the place. If you introduce these diagonals, it stops it, it squares it off, and it can't move anywhere.
So yeah, touching on some of the prep work that we're doing here to make ourselves ready to lift this roof off. Purlins are fairly self-explanatory. Hook them up on the crane, lift them off. But the trusses, we have had to reinstate some temporary queen braces there, which we will be replacing for well-jointed mortise and tenon oak braces when it's on the ground and we can get to it efficiently. These are temporary while we're lifting on the crane, because we'll have a strap that comes underneath the tie beam here up to the purlin housing, and that'll be on a choke basically. So to stop that choke compressing here, we've reinstated these braces so that we can lift them out safely without crushing the truss, because we definitely don't want to crush the truss. They've had a hard enough life as it is. So got these large softwood sistering timbers. You can't see them here at the minute, but that's actually hiding a snap here, which is going to hold this tie beam nice and strong as we lift it off. When it's on the ground, we'll take the softwood off, do the necessary repairs, ready to be lifted back up. So we've got a couple of these. We've got a snap here, we've got a snap over there as well. Basically what happened was the guys that built this place, they chopped out these huge mortises for some ceiling beams either side, and it just took too much meat out of the tie beam, and they've all failed. This one's failed at the mortise over there, and that one has failed.
So there's a mortise.
There's a mortise
behind here.
Behind here, there's a mortise and a snap through the mortise where it's failed basically. So we're not going to copy their failure.
Crikey.
Posts are all braced diagonally, so that because at the minute the tie beam, it's called a tie beam because it ties the building together. If we're taking the tie beam off, we don't want the walls to start flapping around. So we've got lots of bracing everywhere, lots of triangulation to stiffen the building up while we've got those tie beams off. What else have we got around here? Beneath us, the guys are putting some metal strapping on the floor joists so that we can stiffen up the floor as well. Basically, we've got to do everything we can to make the rest of the structure as stiff and as strong as it can be before we take the roof off. Because it will, these purlins, the trusses, even though they need work doing to them, they are still sort of holding the building together a little bit. So,
yeah, I must say the structural engineer on this job is actually quite against pulling things to pieces, isn't he? He's actually on several occasions said he doesn't know actually how it's standing up, but it is standing up, so don't interfere with it.
Yeah, I mean, it was the decision to take this roof off. It wasn't made lightly, you know. There was a lot of meetings and a lot of umming and ahhing about what the best course of action was here. Eventually, we decided that the wall plates were just too far gone to be able to repair. They had to be replaced, and to do that, as I said, you can see the cogging detail in this corner. This tie beam is actually jointed into the wall plate here, and the only way it works is with gravity. So there's no way you could slide the wall plate in from the side, because if you can slide it in, there's a chance, you know, you can always go back out the other way. But the wall plates are held on with lots of vertical tenons from our principal posts, and they're also backed up with many close studs in this frame. But yeah, the mortise and tenon joints on these hold that, and then that captures that.
Cool. Right, well, we'll go and I'll stop here and we will go for a wander and have a look at the maybe the dragon beam too, because that's an interesting part of it. So let's go across there.
Yeah.